Alright, today I want to go over with you the notes number 9, special pairs of angles. Oops, I'm going to change that color. Sorry about that. So, special pairs of angles. Now, one of the things that I had mentioned before is that we are not allowed to use prior knowledge in this class unless it's something that we've covered in our textbook. So there may be some things that you know from the past that unfortunately I can't give you credit for because it's logic that we're not aware of. So it's super important, and I think a couple people had some issues with that on the Chapter 1 test where you were trying to figure out the measure of an angle given an angle, and what you did was use this notion about two angles having the same measurement. Unfortunately, that wasn't covered in Chapter 1, but that's something we're going to talk about today. Now again, most of this information is going to be review for you, and these notes are actually kind of simple today. And this will be the last set of new notes before the Chapter 2 quiz. So first vocab word is complementary angles, and please be very cautious about your spelling. This is not the word we would use if somebody was being complimentary to you or paying a compliment to you. That compliment has, instead of the first D, it has an I. And if you think about it, tell the difference. When somebody is being nice to you, then they are being complimentary to you. In this type of complementary angles, and I'm going to give you how I abbreviate this. Oops. So COMP and then the angle symbol. This is two angles whose measures have the sum 90 degrees. Okay, so anytime I add up two angles, they equal exactly 90 degrees. They're said to be complementary angles. Now, each angle that forms this pair is called a complement. So another vocab word, complement. And that would be each angle of the pair. Oh, hello, maybe if I spelled that correctly, sorry. Pair that add up to equal 90 degrees. Okay? So, in a diagram, and remember that the in our book usually we see a little red corner. That means that we have a 90 degrees right angle. So we form two angles here with that ray. We don't know if it's a bisecting ray. We're not given that information. But what I can conclude is the measure of angle 1 plus the measure of angle 2 equals 90. That is the definition of complementary angles. Two angles whose measures have the sum of 90 degrees. And that's what we'll be using in our proofs. Okay? So the cousin to complementary angles is supplementary angles. And I abbreviate it as supp, S-U-P-P, angles. And they are two angles whose measures have the sum 180 degrees. Okay, and then we do have what each one's called is a supplement, another vocab word. And that's each angle of the pair that add up to equal 180 degrees. And so what this diagram looks like, I think I'm going to go to the next slide and do that. So in this diagram, we're going to have a straight angle and some ray coming out of it. And we're going to have angle 1 and angle 2. And according to the definition of supplementary angles, the measure of angle 1 plus the measure of angle 2 equals 180. Now I'm not going to write the degree symbol on this. So how would we use this? Let's go through an example. A supplement of an angle is 3 times as large as a complement of the angle. Find the measure of the angle. So in algebra, if you remember, hopefully you do, what we look at is what they're telling us to do, usually the last sentence. Sometimes it's written as a question. We look at what it is they want us to find. In this case, it says find the measure of the angle. So that's what we're going to let x represent, is the measure of the angle. But they talk about the angle in other terms. They talk about the supplement of an angle. So remember, the supplement of an angle, the angle and its supplement have to equal to 180. So you can think of the supplement of this angle x to be 100 minus x. So that's the supplement of the angle. And then they also talk about, let's do the complement of the angle. Well, remember complementary angles add up to equal 180, so our angle subtracted, or add up to equal 90, excuse me, so our angle subtracted from 90 will give its complement. Now we go back and we're going to use our algebra skills, and we're going to write an equation using these words. A supplement of an angle. Okay, according to our definitions, that's that 180 minus x is, that means equals, 3 times as large as, so I'm going to multiply something by 3, and then it says the complement of the angle. Well, according to our definitions, that's 90 minus x. So we used our algebra skills to translate the English into a math sentence, and we used our geometry knowledge to be able to define our variables. So first things first, I'm going to go ahead and distribute, and I get 180 minus x equals 270 minus 3x. Now, some of you may notice on the Chapter 1 test that you lost a few points because you didn't show work. Anytime you can do a calculated answer, I better see work on it. And I don't want to see you skip a single step. Our algebra skills have to stay sharp in order for us to be successful in the subsequent class. So I'm going to be a stickler about that. So just know that. Those of you who had me last year already know what my requirements are. So let's keep it straight, folks. So we're going to do opposite operations. I'm going to add 3x to both sides to get all the x's on the left. I'm going to subtract 180 from both sides to get all the constants on the right. The result of doing that gives me 2x equals, do a little renaming as we need to, 90. Divide by 2 on both sides to get x alone, and we get x equals 45. So our answer is 45 degrees. Okay? All right, so here comes the issue that showed up on the Chapter 1 test, that some of you may have had some prior knowledge about this next vocab word, and unfortunately, it was not a logic that we had learned yet, so you could not get full credit if you attempted to use this logic, because you made some assumptions on the test that you knew nothing about at this point, according to our process of learning. So this is vertical angles. And I abbreviate it as vert angles. And these are two angles who share a common endpoint. Hold on just one second. I'm going to go ahead and I'm going to change this definition. Because I'm looking back, and when I originally wrote these notes 10 years ago, and so these are the ones that show up on School Loop, I did a little ad-libbing, so I'm going to make sure I get back the right one. So I'm looking in my glossary, and it's two angles whose sides form two pairs of opposite rays. Okay, so to illustrate, there's one ray, there's two rays, and I'm just going to number two of those angles. There's actually two sets of vertical lines when we have these opposite rays. So we have two sets of opposite rays. They have a common endpoint right there. And what we say that angle 1 and angle 2 are vertical angles. Oops. Okay, so a stickler point I have here is the spelling of vertical. I have students who want to spell it with C-L-E at the end as opposed to C-A-L. I will ding you for that because I want you to make sure you understand what it is we're talking about. You need to learn how to spell regardless of what class you're in. Okay? Now, does it say anything here about how much they measure? What are they equal to? Is there anything, a relationship that exists between them? And the answer is no. Where we find out a relationship about vertical angles is from our theorem. Now, theorem 2-3 doesn't have a name, but it is a super short theorem, and most people memorize it immediately. And it's a good thing to memorize because it shows up a lot in proofs when we're dealing with angles. And this one simply says vertical angles. That doesn't look like an angle, does it? Let's just try this. We'll spell it out. Are congruent. Okay? Vertical angles are congruent. So, I'm going to go ahead and go to the next slide, and we're going to actually do a proof using this theorem. So, remember with proofs, we have a given, and the given is angle 1 and angle 2 are vertical angles. So if you think back to that theorem, it wasn't written in an if-then form. Let's go back to that for a second. It just said vertical angles are congruent. So if I were to write it in an if-then statement, it says if angles are vertical, then they are congruent. All right, going back here, that's our given. If angle 1 and angle 2 are vertical angles, prove, or then, angle 1 is congruent to angle 2. Okay? Now, we're going to have a diagram that goes with this. It's going to look very similar to the one I used in the definition, but I'm going to add a third angle in there. So we've got angles 1 and 2. We're trying to prove that they have the same measure, and then you're going to have this angle 3's involved. So, what do we know about angles? Well, again, so far in this book, we've studied that we can use a protractor to measure the size of an angle. We have angle addition postulate, where two smaller angles add up to equal a bigger angle. And we have the angle bisector theorem, and that's the one that says the measure of a smaller angle is equal to half the measure of the big angle, as long as I have a bisector going on in that angle. So, thinking of those, I have nothing mentioned here about bisectors. And knowing that I have vertical angles does not actually allow me to conclude anything, because the definition just says that we have two angles whose sides are two pairs of opposite rays. But I'm going to go ahead and I'm going to do a little differently than what's in the hard copy of notes. As I'm, by default, we can go ahead and put in always the given. So angle 1 and angle 2 are vertical angles. And you know how I abbreviate, so there's abbreviations there. That would be my given. Now, most of the things I know about angles have to do with addition of some sort, or their measures. So what I'm going to do, and by the way, just in case I haven't stated this before, when you're trying to prove a theorem, you can't use the theorem in your proof. So you can't use theorem 2-3 when we're trying to prove theorem 2-3. So we've got, let's see. If you notice, we've got two sets of angles that form a straight angle. So we've got that one set, and we have this set. Now, if you notice, I overlap with angle 3. So chances are I may be able to do something about this. So let's see, if I add two angles and I form a straight angle, angle addition postulate. So I can say the measure of angle 1 plus the measure of angle 3 equals, in this case, since it's a straight angle, 180. And remember, we don't use symbols in our actual proofs. We can use it in calculated answers. But at the same time, the measure of angle 2 plus the measure of angle 3 equals 180 as well. So that is angle addition postulate. Okay? So let's see. Oh, this is interesting. I have two equations that equal 180. So wouldn't they equal each other? Now we have two options that what allows us to say this. When I'm replacing a piece, a part of one side of an equation, that for sure is going to be substitution. But when I'm replacing an entire side of an equation, I can actually use transitive as well. So you can use either transitive or substitution property of equality here. Now, remember what you want your answer to look like. You want your answer to be angle 1 is congruent to angle 2. So when I write the next step, I need to write orientation of my equation so that angle 1's on the left and angle 2's on the right. So I'm going to take the top equation, measure of angle 1 plus measure of angle 3. And in the right side where it says 180, I'm going to substitute in the second equation, measure of angle 2 plus measure of angle 3. Now, that would be, and again, we could either say substitution property of equality, or we could call it transitive property of equality. You make the choice there. If it's a congruence thing, we can only use transitive. Okay, now I'm going to show you a step that, as far as I'm concerned, is not necessary, but I'm going to show it to you anyway. Measure angle 3 is equal to itself. That's that property I talked about before called the reflexive property of equality. Because I have the same thing on both sides, I can subtract the same thing from both sides. So if I subtract, then the measure of angle 1 equals the measure of angle 2 through subtraction. Now notice the difference of how I did substitution SUBST versus subtraction SUBTR. So again, either you write it out all the way, or at least 5 letters there for the abbreviation. Now, does that look exactly like what we're trying to prove? No, it deals with measures and equality, and we needed to go to congruence. But that's precisely what the definition of congruence tells us to do. So we can use that definition of congruence. This is how I abbreviate, to allow us to go from equality to congruence and from congruence to equality. Now, in the textbook, and sometimes you'll see in my notes, because I wrote these notes, again, 10 years ago, and I probably need to go back and review them, but with everything going on right now, that has been one thing I haven't gotten to. The book often takes step 5 and 6 and makes it one step. If you ever see anything like that, including on the Chapter 2 quiz, you actually need to write both steps. So it took me subtraction, property of equality, to get measure of angle 1 to equal to measure of angle 2. And it took me the definition of congruence to get to angle 1 congruent to angle 2. So please be cautious about this. All right? Good luck.